So I'm taking a look at 2019 Calculus BC, number 1. This is also an AB question. So I've underlined and circled the important information. So for the first question, they're asking us, how many fish entered the lake? Well, we integrate a rate to get an amount. So we want the amount over the 5-hour period from time 0 to time 5. Look at the function. You can see that it's a trigonometric function, so in calculus you need to be in radian mode. So first start by getting into radian mode. So then you're going to integrate the function for the rate entering from time 0 to time 5, because it's hours since midnight, and time 0 equals midnight, as you can see right there. So you integrate this rate. You're allowed to write it like this on your AP exam, even though on your calculator you would type in 20 plus 15 times sine. So on your calculator, here's what you would write. 20 plus 15 times sine of pi x divided by 6. That would go into y1. So you just integrate this. And then, of course, as you guys know, you use the second 8 button. So you go to second 8. So you have to be on the home screen. I'm on the TI-89. And then you would just type, your function would just be y1 of x. So, okay. Oh, sorry, second 7, my bad. So you have second 7. y1 of x with respect to x from 0 to 5. So here's what I typed in. Okay, now calculator jargon is not going to be accepted on the AP exam, but I'm putting this in my video so that you know what to type in. And then just make sure you follow the directions. Nearest whole number. Students lose stupid, lame points for that all the time. So like my mode, if I go to page F2 underneath mode, where it says exact, approximate, right now I have it in auto, so I'm just going to make it approximate. You can also do diamond enter, that will approximate it as well. You do it either way. So when I round this to the nearest whole number, I get 153 fish, because it was 153.458, which is about 153 fish. Let's take a look at question B. So question B is asking us for the average number of fish that leave the lake per hour. That means they're asking us for the average rate leaving, because it says per hour. So remember way back in the day, we would use the average value function when we had the function whose average value we wanted. So we have the function whose average value we want, which is the function L, because that is the fish, the rate of fish leaving the lake. So we would do 1 over 5 minus 0 times the integral of L of t dt, and that will give us the average value. So I already typed in L of t into y2, so I'm just going to type 1/5 or 0.2, this is on my home screen, times the integral, which is second 7, y1 of x with respect to x from 0 to 5. Then, of course, I'm going to read the directions. Okay, what is the average number of fish that leave the lake per hour? So, since they don't tell me what to round to, what place do you round to? Hopefully you guys told me that you round to the thousands place, because you have to round to 3 places unless otherwise stated. Now, another thing to keep in mind to save time, I already had the previous question on my calculator. So I just go before the integral, I type in 0.2 times, and then I just change the y1 to y2, because there's no reason to reinvent the wheel. And so that gives me my answer, which is 6.0 6.05904. Now you're allowed to truncate or round. So this is approximately 6.059. Okay, fish per hour. This is a rate. Okay, we're taking a look at question C. At what time from 0 to 8 is there the greatest number of fish in the lake? Now, we know that this has to be the candidate test or the closed interval test. However, we don't know the amount at time 0, so keep that in mind. If we graph these functions, okay, from 0 to 8, so I'm going to my window. You can't see this part, but I'm going to my window. I'm graphing this from x min 0 to 8, and then I'm just going to go from y min 0 to, say, 200. I'm sure that's way too big, but at any rate. Now I'm going to graph it, and I'll be able to see which one's on top. So my y1 graphs out first, and then my y2 graphs out second. So I can see that y1 starts off greater. So that means that the rate entering is greater than the rate leaving. So you will see that these intersect. So here's what my window looks like. So I have the rate entering and I have the rate leaving. This is what I'm interested in, because during this time, from here to here, the amount of fish is increasing. So the amount of fish cannot be greater prior to that, and it can't be greater after that, because then the amount is decreasing. So you can get around the candidate test here. You don't have to use the candidate test because you can justify. All right, now that intersection, you would go to F5 and you would choose intersection, which is choice 5. It's going to prompt you, first curve, enter, second curve, enter. Lower bound, you're to the left of the intersection. Upper bound, you'd be to the right. If you don't feel like waiting, if you're impatient like myself, just type in 8. And so it will give you the value. Okay, 6.20356. But you can store this value. So I'm going to store this. Okay, well, I don't need the amount, so I actually don't have to store it. So you're just going to round to the nearest 10,000th. So the answer would be 6.204 hours. And then you would have to justify. You'd have to say, well, since E of t is greater than L of t, okay, from 0 to 6.204, and then L of t is greater than E of t from 6.204 to 8. That means that it must be a maximum at 8 because, at 6.204, because 6.204 is a relative maximum. Not only is it the relative maximum, but since it's the only critical point, it's also the absolute maximum as well, since it's increasing up to that point. So you'd have to write that explanation. So hence the greatest number of fish is in the lake at time 6.204. Okay, so taking a look at part D. Is the rate of change in the number of fish? Now they're talking about the rate of change in the number of fish, increasing or decreasing. So in order to study that rate, we would need to get the second derivative. So the second derivative would be E prime of t minus L prime of t. Okay, so we would need to know what's happening at time 5. So my syntax on my calculator for doing this is that I have the derivative, so that would be second 8, okay? And then I get this on my screen, and then I have y1 of x minus y2 of x with respect to x, close that out, such that this bar, x equals 5. When I do that, I get the answer of negative 10.7228. So I can write that as 2, 3. And so since that's less than 0, then you would be able to say that the rate of change in the number of fish is decreasing at time 5. So the rate of change, okay, in the number of fish is decreasing. All right, thank you.